I'm Shadi Ashnai. I'm going to be talking about new in image and audio processing. The new capabilities we are adding is basically aiming towards having smarter, more integrated, and more applied capabilities. Looking forward to seeing you. Hello, everyone. I'm Shadi Ashnai. I've been doing this for a couple of years now. What's new in image and signal processing? This year we named it image and audio processing because audio is still evolving a whole lot. There are a whole lot more talks from the team in this conference, and they are all more in depth because they have more time to talk about specific contents. Just to show briefly what has happened since last year in the domain of image processing, this is just a list for 11.1, Arithmetics and Statistics, more computer vision, photography, microscopy, ILD stuff as Stephen keeps talking about it, and file format support. The development continues into 11.2. The list never gets shorter. 11.3, these are just the things that we have a rough prototype of it, either in the version that you have received or in the nightly builds that we are playing with. So promising feature that is coming, but still probably a lot more than this is going to be eventually into the 11.3 build. The audio features list is not even shorter. We have continued with audio GUI development just to make it more robust. Last year, when we just released version 11, audio GUI was not so mature, so we continued developing on that, added capabilities for audio capturing, more analysis, processing, and things like that, and of course, as well, more file format support. 11.2, again, a fairly impressive list of capabilities. I would say most importantly, the programmatic playback, which is going to take us to the real-time processing of the audio objects. And then yet again, the 11.3 upcoming list is not even shorter. It's just great for me to see that as all the areas in the Wolfram language, the language itself help us develop faster and faster. And after 10 years of developing image processing, the pace is not slowing down. Audio, same thing, and I'm hoping soon we're going to be talking about video. Not today. All right, so impossible for me to cover all of those, but I thought I'll emphasize on the main goals that we are trying to follow. Down the road, what do we want to see Wolfram language being able to do in the domains of image and audio processing? I think very quickly on this intro slide, and then I'll go into the details. We would like to have easier access to data, whether it's import or other kinds of image audio capture or data access. We want to make that as easy as possible and as immediate as possible so that you don't have to worry about that. We are making the functions smarter so that a user who doesn't necessarily need to know algorithms for image processing or speech analysis or any of that is not feeling comfortable approaching our system for finishing or solving a task that is dealing with algorithms for image segmentation or edge-preserving smoothing or detecting formats from an audio signal to come to a conclusion about the speech signal, but just use the machine learning, use the neural networks, and use all the strength and the language to make sure our functions are higher level, smarter, and more to the point for whatever task that has to happen. We're trying to be more applied, looking into different verticals. Roger this morning talked about computational photography, for instance. We have been looking into computer vision, photography, microscopy, specifically for the image processing capabilities that we have. We think those are the relevant market, but also trying to plan and look into many other markets. I know you're coming from diverse set of application areas, and this is a great opportunity for us to interact and know what are the interesting features that you look forward to have in the system. Let us, give us feedback. Let us know what are your interests and what are the missing features so that we can keep building on them. And then now that we can bring audio signals in, I think the two big verticals or application areas dealing with audio signals is going to be speech and music for us, that at least the first ones that we're going to be looking into. I think down the road we may be looking into machinery sounds and things like that, but again, give us feedback on what are the things that we should be looking for, what are the big markets out there that are looking for tools that will solve their problems. We are trying to be as integrated as possible with the rest of the system, just because we see that our subsystem is much stronger, much powerful, and much more useful if it is integrated with the rest of the system. So we are building the bridges to make the connections. We are making consistency update whenever we see that, well, the design of this or that feature that we have added is not super consistent, not easy to remember. We're trying to fix all of those. And obviously, we are trying to be feature complete as much as we can. And then one last thing, we are trying to document things as well as we can so that you can train yourself on individual functions that we are releasing based just on the ref pages that are available in our documentation. All right, so let's get started with actual updates that has happened. For easier access to data, import is obviously the first go-to for bringing data in. GIF, PNG, TIFF, we have had major updates about them, especially with multi-frame versions of them. FITS is another one that we are putting major improvements into it. Astronomy applications strongly depend on a good FITS import-export. And then M4A, which is the major file format that is created by Apple products, basically, is added for audio signals. We used to have current image before. I don't think anyone here hasn't seen a demo from current image. So this connects to the webcam and gets an image from the camera. But now we have other things, other ways of bringing images in, like current notebook image or current screen image, which in my case, in fact, it's going to be fairly similar because I'm doing a full screen thing. Web image search, Steven showed that last night as well, is a very interesting, quick way of getting access to images from the web. So let's see if we can get this going. All right, apart from the error message, we have some thumbnails of hippos. GeoImages give us access to satellite images coming from different servers, as it was discussed and brought up earlier. And then other ways one other way of creating, going from all the computational geometry capabilities that we have that create meshes and mesh regions and so forth, or just the region specification. This is actually a raster image. If I actually, unfortunately, don't have the toolbar that we typically get. But the get image information, it's a 360 by 360 or whatever dimensions you specify and so forth. The good thing is that we have a 3D version of this. So unlike rasterize, that we have it only for 2D, or even it rasterizes 3D graphics and 3D regions into 2D raster images. Now, region image is a function experimental still that gets a region in and tries to do typical algorithms, marching cubes and things like that to construct an actual 3D volume of pixels associated to the region that was specified. And then the last thing, back to the audio domain, audio capture is another function that we added. We had the system dialog input sound or record sound that got updated. This, I think, is a more modern way of, and actually a lot more robust way of recording audio signals from your microphone. So we'll start recording, and then once you stop, an actual audio objects come back. OK, so the functions are becoming smarter and higher level. Broad use of neural network and machine learning. Image identify had been in the system for a while. This gets one image in, identifies what is the content or what's the main object seen in the image. I should have downloaded the networks. Maybe I'll start just running all the other ones as well. Image contents, which has been in the builds, I think, since version 11.1, is not yet documented. But as soon as, again, the networks come in and we see the result, this is trying to look into the contents of the image and give a data set of what are the different objects it can find. So unlike image identify that is seeing only the main object of the image, image contents drills in and tries to see different objects that are available in that image. Wanted to see if I can go hardwired to be faster a little bit on those. Yes. And then more things that are coming. Net model, you have seen already as well demoed in the keynote last night. We are converting a whole lot of pre-trained network into mathematical neural net models that can be represented and then used. Okay, so this is the result from image contents. Let me actually just start getting this other network as well while talking about that. So image contents gives us the bounding boxes, the concepts associated to those objects detected in those bounding boxes, dimensions derived from boxes, images, positions, all derived from that, and then as well probability. So it says how confident we are in detecting that object. So, all right, so back to this other network. Actually a lot of image processing and still nothing for audio on the net model, but hopefully soon there will be something. This one is doing some kind of a depth estimation based on the image, so associating a relative depth to each pixel in the image, and then once you have that, this is just a visual that says roughly how the depth estimation algorithm works. But as you see, these are more higher level things that you don't have to really worry about how the algorithm is doing all of that. We're trying to, again, put together functions that are directly usable for general applications. Combined functionality to build higher level functions is one thing that we probably started on first in remove background. A lot of it is already in the system. Things like solve and ND-solve and things like that are already trying to combine a lot of algorithms into one. Some of image processing functions do it as well. Remove background, in fact, links to a lot of segmentation function under the hood to try to infer what algorithm would work better for removing the background and things like that. So combining a whole lot of different features together so that you get one powerful function, one go-to function to solve your problem. And then other things like facial feature that is as well upcoming probably takes more because it requires multiple networks. But this one, for instance, uses a neural network for age estimation, another one for emotion estimation, gender estimation, one for detecting landmarks on the face, eyes, nose, and things like that. And then all of that combined, you get in one place all the necessary features for doing any kind of face analysis. In case if you haven't been downstairs at our booth yet, there is a very cool demo for doing different kinds of face analysis downstairs with your face captured through the camera. I guess we'll just skip waiting for this particular network. It may take a little longer. More on target, more in detail. I think tomorrow there is going to be this talk by Julia and Mikhail on face analysis and OCR. Again, more on target. Neural networks for images and neural networks for audio, both, well, one on Friday, one on Thursday as well. Oops. Okay, well, if it doesn't work, I'll just give up on that. Basically shows you how you can use and leverage the neural networks framework to build an image processing or audio processing capability into the Wolfram language. So we talked about the fact that we are trying to be more applied. I already showed a few demos for computer vision, and then down the road some other verticals that we're going to talk about. Face analysis, I think it's going to fail again. You saw enough of that failing. Text analysis. In fact, nothing much in the version of 11.3 that you have, apart from the update that we had, I think, in version 11.1, where we can specify second, third arguments of text recognized, being the granularity of the text that we would like to detect, the whole thing, lines, words, characters, and things like that. And then we can also ask for properties like bounding box as well for strength or the confidence in the detection of the character and things like that. And then this is just basically the same example with words. What is going to be very major for OCR is the detection of the text. Again, we are working with neural networks to be able to detect the location of the text, which is basically the ultimate goal is to make the recognition better, but the detection is obviously the first step to do the detection, so all of that is going to be coming as well. These I think I've already done once. Again, in the computer vision, we are doing, we have already done things like image identify, image contents, and fairly easily highlight things on top of that to see where we're going. But also things like motion tracking, where we can do things like image displacement of a series of images. If I do something like oh, sorry, list plot of that, list animate of that. So you'll see we have some rotating object in there, and in order to understand what's happening in the image, we can do displacements, compute the curl of the displacement in order to find the rotation and some kind of a heat map of where objects are more rotating. As for the domain of microscopy, we have spent some time putting together some examples that are targeted to the people working with microscopes in different fields, biology, material sciences, and quite a few more, actually a lot more, working with microscopes. One thing for dealing with microscopes was basically bringing data in. Typically, microscope vendors work with various commercial specific file formats for them. And this bioformats library is the one that actually gives us access to 150 file formats. Piotr talked about this earlier today. The recording should be available. And this was a Java library with JLink. We actually connected to it. The library is available online on GitHub, open source. And then we have done a lot of analysis and processing examples in this blog post that got released earlier this month. We have connected to this Zeiss microscope, doing different things like brightness equalization, color demixing, viewing and manual measurements, 3D focus stacking, and 3D reconstruction. As well, actually, in the booth we have downstairs, you can come and play with the microscope and talk about more applications that we have done. And then things with machine learning and neural networks, doing things like image classification or detection of the last example here. I'll let you go through it. It was too much. I decided I'll just leave you with the link to go through. As I said, for astronomy, we have done a good update on fits, and then things like brightness equalization that is also applied to microscopy is applicable to astronomy applications, where you have dark fields that you would like to use in order to get a more uniform background. And then this is basically the result of that. Photography, image effects, and maybe I should as well start evaluating everything here. Some of these we have shown last year, additions from last year, more effects in image effect for things like sepia, color tones, jitter, but also a lot of framings that often is going to be useful when we're blending images into each other and then composing an image on top of itself and things like that, you know, kind of just, oh, this is not responding because, well, why? Because of some other things I'm evaluating, maybe. I'll just let you play with that, as I don't have a whole lot more time. But image restyle that has been demoed a lot today, things like restyle with template images, like the 4 images of paintings of 4 seasons, but also you can use image itself, like the edge detect version of the image to do restyling, or quantized version of the image to do restyling and things like that. And talking about quantization, one of the additions as for incremental improvements is to get more methods, faster methods, better quality methods, like color quantize was updated with newer methods that are actually performing much better than before. HDR image creation, for those doing computational photography, we had a function called image exposure combine that took differently exposed stack of images, combined it together to get a good exposed image all over. But we also added a small modification to it so that the user can get back, you can get back the HDR version of it, just in case you have an HD high definition display to display it on, or in case you want to do your own color tone mapping on that and don't want to rely on our color tone mapping that is baked into the function. As for speech synthesis, I think a more detailed version of what's coming, nothing much baked into the system yet, is going to be in Carlos' talk on Friday. What is in the builds and is new, I'm not connected to the internet, I believe, here. Sorry, the sound. I don't quite know how to work with the volume here. That's okay. Probably we don't have a lot of time to. But all of you know what Speak used to do. speak the word, the sentence, hello, Wolfram, to the talk, speech synthesizes the function that actually gives you the audio waveform to then process, analyze. It's not coming out. Something might be wrong with the, yeah, that's okay. Well, we'll go without it. I don't think it's going to be. And then, well, won't be able to play this again, but we have access to different voices, different methods, and things like that to do speech recognition, speech synthesis. Speech recognition, very, very much under development. We're trying to make improvement into our neural network framework in order to be able to handle audio as well. I'll just probably leave this for us as well. But what it does is basically we have used a very small data set of speech. Maybe I'll try to at least see if audio capture may work. All right, so we have trained a small network with 150 recordings of different digits 0 to 9, 3 speakers. The data set was available online. And then this trained network that is imported is supposed to recognize the digit that is in the audio signal. Okay, let's try this. 3. Okay, that's the audio signal. That's the plot of it. These are the parameters we would like the network to use. Well, I wasn't saying it close enough to whatever the trained, yeah, and I think this is, as I said, very much under development. I really didn't expect it to do the right thing. Some of the example I was playing with actually worked. Okay, more integrated. Region, okay, raster image to mesh region. So we have, we would like to make a bridge between images and regions. So here we have a binary image we call image mesh and go from the raster image domain to boundary mesh region. We can do different things now in that domain that is not easily doable in the image domain. And then we get a 3D printable region, basically. As well for 3D, as I said, region, the image mesh is also available there. So we get a 3D volume, we do some binarization, and then we convert it to a region that then we can do other modifications like transformations or anything else that might be easier, faster, or well-defined, better defined on that domain. Going from regions to images, the other way around, is also implemented in this experimental function called region image. So here we have this mesh. We do some smoothing and then convert it from a raster image to a mesh. And then here is another example with a 3D region that we rasterize into a 3D image. The good thing about the function region image is that it's not platform specific like how rasterize was. So if you're doing something that requires creating a mask that you would like to be consistent across platforms and so forth, this is basically the go-to function. The other thing that was added was the function image graphics. The goal of image graphics is to go from raster images to graphics, to scalable vector graphics. I think the holy grail of that would be to convert scanned plots and things like that from very old papers to actual graphics that have proper ticks and proper plot lines and all of that detected and put together. The current version of it, again, experimental because of some design uncertainties we had, but the current version basically only detects 2D segments of an image, 2D regions in the image that are of similar color and try to form a scalable vector graphics. So if I basically scale the input image here, you see that at some resolution it starts to pixelate because it is a finite dimension raster image, and this is the image graphics version that is actually scalable. And then this example, I'll just leave it to you to play with it. We're starting from a simple, we're starting from an actual image and trying to create an iconized vector graphics icon from it. One other addition for a better integration is wavelet support for audio, something we didn't find time to do it for the release of audio in version 11, so we added that. What is happening here, unfortunately, I can't again play the audio objects.
You will return safely to Earth.
Oh, okay. This actually happened.
return safely to Earth.
So this is the noisy signal, and after going through wavelet transform, wavelet thresholding, some of the noise is gone. So I think it's going to be valuable just to have all of it available and so forth. Arithmetics and statistics operations on images has been added very recently. So just like we could do arithmetics on time series for a while and then on audio in version 11 as it got released, I can get an image, do some color quantizations, do some dilation and things like that, multiply one image by 2 and then subtract them from each other to get any effect that you want. And this can be as sophisticated as you want. Also, statistical operations just directly are available, things like min, max, median. It seems trivial, but it actually takes a whole lot of development effort to get those working and get them working consistently. One thing that we changed for audio, in fact, for statistical operations is that if we do have a multi-dimensional audio object, and if, regardless of audio or image, what we do is that we take the data out and we just flatten it so that the spatial dimensions of the pixels are flattened. So we keep the channel 1, channel 2, channel 3 syntax. And then we pass that to the function. So if we have an RGB image, we basically just flatten it for all the rows. So just have a flat 1D list of pixels, but still keep them RGB, RGB, RGB. And then if the function min in Mathematica gets that two-dimensional array of RGB, 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 and gives one number for minimum, we also do the same thing and don't treat it any differently. We give one number for the whole minimum. But if the function mean actually maps over those channels, we as well map over channels for image objects, similarly for audio object. I think this was one of the difficult design discussions for us to make sure that this, now that we have come to this conclusion, it seems trivial, but I think, anyways, it's very good, convenient how, to remember how all of these work and how do these relate to the original behavior of the functions. Metadata support under development. For images, we have had them for a while. For audio, we're going to be adding them. Another addition, as I said, quickly demo this, programmatic playback. We have an audio object. We have added this construct or wrapper called audio stream, which is basically a handle to the audio object that we can start playing. And then it has properties like how the channels are assigned, whether we should loop, what's the device, what's the position, and what's the status, playing, paused, or what. And then this is, for instance, the properties for that single audio stream. We can have multiple streams attached to single audio object, which can be started to play at the different times. Here, for instance, I play one, pause half a second, start playing the other one. And this is just a simple example. Weird. Yeah, I don't know what's going wrong there. Another one? Okay, so here we are basically creating our own player where I can start playing, pause it, restart playing, and so forth. And down here we'll see just the progress bar. So this is like a mini player put together with the audio stream capabilities. Better documented function, I'll just jump to one of the functions, mean shift filter. We are making the documentation cleaner, but also a lot more intuitive. We are trying to insert these illustrations. Maybe I should just make that a little bit bigger quickly. We're adding descriptive text on top of all of the functions explaining what this function is supposed to do, and then adding illustration, and then the filter cases, we're doing one 1D, one 2D, for instance, but also details about what is the coordinate system this function works in and things like that, which is a lot easier than going through the text and trying to visualize it in your head. And a lot of examples are being added. I just did a quick run. We now have over 350 functions overall for image, audio, and signal processing, over 4,300 examples in all of them. So some of them, like audio plot, has a lot of examples because it's a plotting function. It has a lot of options and things like that. On average, we have 12, and then some of them, have fewer. If you have any question, this is the team of experts on image and audio processing, import-export of these file formats. Look for all of us. And there are, in fact, a whole lot of other talks that go more into depth and details of all of these functionalities that I try to very quickly highlight. Thanks.